lesson 4.3, transformations of logarithmic functions. We're going to see today how we can transform logarithmic functions in a similar way to the functions that you transformed last year in grade 11 math. Just to get us started, let's remember how different transformations affect a function. So if I have a function like f of x minus c, this becomes a translation up or down. If I have a function like f evaluated at x minus d, this corresponds to a translation left or right. If I have a function like a times f of x, this is a vertical stretch or compression. And then finally, if I have a function like f evaluated at k times x, this corresponds to a horizontal stretch or compression. As well, our vertical stretches and our horizontal stretches can also become reflections if the a value or the k value is negative. So let's look at an easy example to start off with, a translation question. We'd like to graph this function, and then we'll state the key features of the function, such as the domain and range, the intercepts, and then any asymptotes. Let's first talk about the key points of the common logarithm function. And keep in mind that the common logarithm can be written as 10 to the power of y equals x. And that's where we get our key points from. So the key points being an x-intercept at x equals 1, or a coordinate of 1 and 0. There's no y-intercept because there is a vertical asymptote at x equals 0. There's also a point at whatever the base of the logarithm is and a y value of 1. In this case, since this is a common logarithm, we have a point at 10 and 1. And we use this information to transform our function. So I'm going to use an SRT table, stretch, reflect, translate. So this function has no vertical stretches or reflections, but we are moving this to the right 2 units. So for every x value we're adding 2, and we're moving this whole function down 5 units. So we're subtracting 5 from every y value. So my point at 1 and 0 going to be moved. I'm going to take the number 1, I'm going to add 2 to it. So my point at 1 becomes a point at 3. And then my y value of 0, I'll subtract 5. So my point at 1 and 0 becomes a point at 3 and negative 5. My second point at 10 and 1, again, I take the number 10, I add 2, so it becomes a value of 12. subtract 5, get a value of -4. I can also shift the vertical asymptote. My original asymptotes had x equals 0. I have to add 2 to every x value. This is going to become an asymptote at x equals 2. I can use this information to graph my function. You can see on my graph I've marked in my scale. I'll show my asymptote through x equals 2. I'll mark my point at +3 and -5, and my point at 12 and -4. So my graph is going to look something like this. And finally, I'm being asked to find the key features, the x-intercepts, and the equation of the asymptote. We'll do the domain and range last, actually. Let's start with the x-intercepts. X-intercepts happen when the y value is 0. My equation is 0 equals the logarithm of x minus 2 minus 5. I can rearrange this algebraically. So 5 equals the logarithm of x minus 2. And now I'll use the identity of what a logarithm is to rearrange this. I'll take my base, which is 10, raise it to the power of 5. That'll be equal to x minus 2. So 10 to the power of 5 plus 2 will be my x value at the intercept. 10 to the power of 5 is a huge number. It's 100,000. Plus 2 equals my x value. So my x-intercept is going to be at 100,002, the y value of 0. For the y-intercept, we can set the x value equal to 0. And solve our logarithm. Here we run into trouble. I have a negative number inside my logarithm. The logarithm function is undefined for negative values. What this means is that there's no y-intercept. vertical asymptote, we can look at what is inside the logarithm function. So we have x minus 2 inside the logarithm function, and for the logarithm to be defined, what's inside the logarithm function has to be greater than 0. So rearranging this algebraically, x has to be greater than 2, which means we have a vertical asymptote along the lines x equals 2. And we had already found that when we were graphing. So we go back to the beginning, domain and range. Our x values are an element of the real numbers such that x has to be greater than 2. For the range, there are no restrictions. Y is just an element of the real numbers. The y values will take on any value eventually. Tomorrow in class, I'm going to start with this example, another sketch of a function. If you want to try this right now for homework, please do. But otherwise, we'll start with this in class and do a few other examples of sketching